Welcome to another episode of Python tutorial series. In this episode, I want to talk about the basic array in NumPy and how to create a basic array by NumPy. First of all, we need to import NumPy, and we say import NumPy as NP, as usual. And the first array I want to create is the array of zeros, and we need sometimes in some application we need to create a NumPy array with a specific size, a specific shape, but we want to initialize the integers of the array by 0. So this 0 command help us to create this array. For example, if I say np, if I want a NumPy array of shape 3 and 4, for example 3 and 4, all of them are 0, I use this command. So you can see that I have an array of shape 3 and 4 and all the entries are 0. The second one, or another example of this one could be something like this, zeros, for example 2, and when I use a single integer here, it means that I have one-dimensional array, and but if I ask the shape of this array, you can see the shape of this array is 2, and in NumPy we have this syntax 2, nothing, which means that it is one-dimensional array. Another basic array is array of ones, and the command is similar, but instead of zeros we use ones. And for example, if I need an array of shape 2 and 3, 2 rows and 3 columns, all of them are 1, I use this command. And again, this is similar for one-dimensional array or higher dimensional array. But for sometimes we need to have a scale on the NumPy array. For example, in the application in Matplotlib, and when we want to plot a graph, we need to have a scale on the NumPy array. And in this case, we use np.arrange for this case, and np.arrange start from the minimum member of the array and the maximum number of array and the step size. For example, in this case, I want to have an array between 0 and 5, but I don't want 0, 1, 2, 3, 4, 5. I want a step size to be 0.1. So the first element of the array is 0, the second one is 0.1, the third one is 0.2, and so on. And you can see that we have this scale here, 0, 0.1, 0.2. So the first element, I can write it here, is mean, minimum value, maximum value, and step size. But there is another method doing the same thing, but sometimes we don't know the step size, but we have control over the number of points in the array. For example, I want an array of np that I use linear space, and this is again minimum value and maximum value, and here I don't have a step size, but instead I can say that I need 20 points in this NumPy array, and it automatically calculates the step size and create this array. And you can see that the minimum is 0, the maximum is 5, and the step size is something like 0.26, but roughly, and it creates this array. Both of these methods have application. It depends on that. If you want to have a control over a step size, you can use the np.arrange, or if you want the number, have the control over the number of the points in the grid, you can use the line space. Both of them as application. But Also, we could sort NumPy array, but np.sort, and it is very easy. For example, if I have an array A, and I, for example, I can have, for example, 4, 3, 7, 2, 9. Sorry, np.array, sorry. And I can use np.sort A, and you can see that it sorts the array from the smallest element to the largest element. And the final things I want to cover today is the concatenation of two different arrays, and again it has many applications. Suppose I have an array x, which is, for example, np.array. It is two-dimensional array, for example, 1, 2, and 3 and 4. And I have another array y, which is again two-dimensional array, but is, for example, 5 and 6. I can use np.concatenate to concatenate these two array x and y, but it look at the shape of the array x and y, and it is impossible to concatenate in the columns, so it concatenate on rows, and it adds the final rows to the end of the rows, because I have the first row 1 and 2, the second row 3 and 4, and the third row will be 5 and 6, which concatenated behind the other two rows. But I can have a control over the axis of the array. For example, the axis in this case is 0. 0 means the rows, axis 0 means rows, axis 1 means columns. So when I say concatenate x and y over axis 0, it means that concatenate the rows. But if I change it to 1, it has a value error, because it cannot concatenate these two on the column. But if I change for example, let me change it to 0. If I, for example, change this one to 7 and 8, then we have two same shape array, and in axis 0, you see at first we have x, and then we have y rows. But if I change this to 1, I have another result, and the result is that I have columns of x first, 1, 3, 2, 4, then columns of y, 5, 7, and 6, 8. And this is a different way of concatenation by having access, by having control over the access that we want to concatenate. Thanks for watching this episode. And in the next episode, I want to talk about broadcasting and how to calculate the operation on the different array.